Hello and welcome to episode 5, sorry, of maths. Today I'm going to be using implicit differentiation to solve tangent lines, or tangent lines using implicit differentiation, and we'll be using dy divided by dx. So the equation for this graph that I made was x squared plus y squared is 25, and that's why it intersects at 5 on the x and y axis. But as you know, or you may not realize, is that every time you move along a infinitely small amount, then your line bends slightly. So it was like that, and then you move along to about here, and it becomes a bit like that, and then you move along to about here, and it becomes a bit like that, and then you move back here, like that, here, like that, and so it's infinitely an infinitely small rate changing, and that's why we get this circle. And just as a kind of example to explain, here are some. They're not actually what it looked like, just trying to explain it. But this is how they slope in the positive part. In the positive negative part, they slope like this, and in the negative they slope like this. And I guess from that, it's very easy to calculate how they do it in the negative positive. They'd be like that. So, moving on. This graph was 9x squared plus y squared equals 45. So that means when x is 0, so that's all 0, then with a y-intercept is the square root of 45. Now, we're going to find out what these kind of lines are when we reach the point 2,3. And just to check, in case the textbook is wrong, although this isn't textbook's work, the point 2,3 does occur in this equation because how we graph is we go along by x, then we go up by y, so then that's xy, so 2 is our x, 3 is our y, so put them into the equation. 9 times 2 squared, like this part, plus 3 squared does equal 45, because then it equals 9 times 4 plus 9. You could do it algebraically and take out this plus 9 and use it to do 9 times 5, because it's an extra 9, or you could just do it this way, which is 36 plus 9, but either one works to 45. So let's solve the tangent line for the point 2,3, and just a note, we're going to be using derivatives, so get your derivative mind into gear, because the derivative of x is 1, as you may know, but in this case, using the derivative but in cases of x, the derivative of y would be dy divided by dx, and then they would be separate. So y would become dy divided by dx, but of course it was like y squared. And also another sign for the derivative is d divided by dx. So that would then become 2y. So the 2 and the y stay together, and then it's then multiplied by dy divided by dx. And because they're separate, then you can start doing like divide by 2y and things like that. So here's our equation. Let's find the derivative of everything first. So the derivative of 9x squared, we take the 2, we multiply it by the equation, then we take the power and do minus 1. And because x to the power of 1 is just going to equal x, So then it's 2 times 9 times x. 2 times 9 is 18. 18 times x is 18x. Y squared, as I showed you earlier, just take the 2 minus 1 times dy divided by dx, 2y times dy divided by dx. And 45 becomes 0, and this is because of the constant function. Very simply, all the constant function is the derivative of, and it's a sign I can't draw, so I'm just going to write a, but it's the alpha sign, where a isn't part of the graph, because this is the x-axis, this is the y-axis, and you can even have a third one, which is the z or the z-axis. But anyway, the constant function, any a, so any real number, is always going to be equal to 0. That's simply what it is. So 45 is our a, and it becomes 0. So then we put them all together, and we found the equation. And now we need to solve for dy divided by dx. So we can do minus 18, and then we get 2y dy divided by dx equals minus 18 divided by 2y, and there we go. Then we just simplify from there, and then we can use the algebraic rules we learned in the first episode to keep it like this. But we're not done there. So we know our points are 2, 3, so now we have to put in our x and y axis, and then we'll get minus 6. And that's our slope for the tangent line, because it's going to be a straight line. It always is a straight line. So that's our m, if you remember. Straight lines are y equals mx plus minus c. So that's our m. So all we have to do now is solve. So our x1 and our y1 are 2 and 3. And this is basically the equation we use to solve. So we put in our coordinates we were given, which become that. Let's tidy up this bracket area. And now let's do plus 3. And now let's do, well, that's just it. And to check that the equation is correct, because sometimes they can be much more complicated, just sometimes. We'll put in 3 and 2 into the positions, and it still works out. 3 equals 3, believe it or not. So now we can say that the tangent line, using a rule of 9x squared plus y squared equals 45, passing through the point 2, 3, is y equals negative 6x plus 15. And that's what it looks like. So that's our y 9x squared plus y squared equals 45. And that is y equals minus 6x plus 15. And just the last point, if you know the two equations, if you know the tangent line equation, and if you know the equation for your graph, but you're asked which point do they intersect, turn them to terms of y. So all we have to do here is minus 9x squared, and then just square root it to get rid of the squared and the y. And same, we know what the tangent line is. Now we already know that what the answer here is going to be. It's going to be the point 2, 3. But here's how you solve it. So because they're both in terms of y, and it's the point where they intersect, this y and this y must be the same. So these two equations must equal each other. So we get rid of the square root by squaring. And now we solve the quadratic. Tidy the quadratic up. Now we're going to do 2 steps here because I ran out of space. We're going to do, now these two can be done simultaneously. So 9x squared plus it, so that gets rid of the 9x squared here and adds it here. And negative 225 gets rid of it here and puts it here. There we go. All our x's are on this side, and all our numbers without any variable value are here. So negative 180 equals 45x squared minus 180x. Now here we have to do divide by 45 and then square root, because the square root is just equal to the power of 0.5 or to the power of 1/2. Now dividing by 45, 180 becomes minus 4, minus 180 becomes minus 4. That of course becomes x squared, and that becomes negative 4x. All of these can be square rooted or divided by 2, whichever one. So then this becomes negative 2 equals x minus 2x. Then using the algebra again, we can find that x is common here. Put it here. Now we've got constants in here, so let's solve the constants. 1 minus 2 is minus 1. So then that's minus 1 times x, which just becomes minus x. And because both of these we want positive x, we're going to take away the negative. Whatever sign here, we're going to flip it. So then we get 2 equals x, and some people just like to do it this way, so it's easier to read. We swap it around to make x equals 2. And now that we've got x equals 2, we'd just plug x into there and find y. Now we'd use the easiest way, but it's always best to do both ways just in case you messed up in your equations over here. So we'll put 2 in there, negative 6x, negative 6 times 2 is negative 12, plus 15 is positive 3. So now we know our x and y coordinates, but just to check, oh god, 2 squared is 4, 4 times 9 is 36, 45 subtract 36 is 9, square root of 9 is 3. So there we go, and 3 equals 3. So there we go, that's how you solve them. Linking on, this is called implicit differentiation. You can also get another one called logarithmic differentiation, and that can get quite confusing, and you have to use special log properties, which I haven't done a video on yet. I might do a video on, I think I'll probably do a video on, actually, you know what, now. What should I do? Actually, yeah, I'll do a video on them, and it's for things like logarithms are log something. You can also get log something into something, and this is another part of logarithm. And that's called a natural log. Oops. That's called a natural log. That's called a neutral log. And that's called a logarithm. So yeah, like, subscribe, leave a comment. And that's it basically. I'll just go PowerPoint by PowerPoint just so that you remember. This is what it's called. Here's some of the examples. This is what you have to do, and a note about this. These are the equations you have to do. This is how to solve. This is what my one looked like afterwards, and here is 2, 3, they come meet here. And if you have the equations, then all you have to do is turn them in cases of y. You could do it in cases of x, but that's much harder. And if you're given the tangent line, it will always be in terms of y anyway. Although you could turn it into terms of x. And then just make them equal, solve it in terms of x, positive x that is, whatever your answer will be. I don't know if it will be positive or negative. and then all you have to do is plug x into both the equations to make sure you got it correct, and then just use them as your x and y coordinates so that you know what the coordinates were. That's it. So, like, subscribe, leave a comment again, and I will see you later. Bye.